to begin CO58. And in CO56, we talked exclusively about the x-intercepts. Given the x-intercepts of a parabola, you can write the original equation. And we talked about how many x-intercepts a parabola can have. Given the basic rundown of the number of x-intercepts you should always be looking for when solving for them or be given them. Yeah, Kylie. Two. Why?
Because the parabola can like loop around.
Right. The parabola comes down, crosses the x-axis, and goes back up again. Right? Or it goes up, crosses the x-axis, and goes back down. Okay. So you always have to be open for there being two solutions or two x-intercepts to a parabola. When would there only be one x-intercept? However, when would there only be one? Alex?
The parabola is at the top, so the x-axis is like x-axis here.
Okay, I think you meant a different word than parabola.
Oh.
Arlene?
When the vertex touches the x-axis.
Right, when the vertex is on the x-axis, right? Because that's either the highest it's going to get or the lowest it's going to get. Okay, it's going to touch the x-axis and then zoom off, never to be seen again. Okay? And then what's an example of when a parabola would not have any x-intercepts? No x-intercepts. What would that look like, Aiden?
It's just off to the side somewhere.
Off the side somewhere, it doesn't cross the x-axis. Okay? So you've been kind of familiarized with this before. And there's something in algebra called the discriminant. And the role of the discriminant is to tell us how many x-intercepts a parabola has. Not what the x-intercepts are. You have to actually solve the parabola to find it, but it does tell us how many there are. Okay? And the discriminant is another formula. So we have the vertex formula, right? We have the axis of symmetry. There's a formula for that. Here's another formula. The discriminant is b squared minus 4 times a times c. B squared minus 4 times a times c. And if you're wondering, where did the a, b, and c come from? Well, remember that the parabola in standard form, right, has that a, that b, that c. That's where those values come from. Okay? So again, the discriminant tells us how many x-intercepts it has. And the discriminant is the formula b squared minus 4ac. If this value is a positive number, doesn't matter what, is anything positive, there will be two x-intercepts. Okay, which means the parabola either looks something like that, or it looks something like that. Okay, it'll touch the x-axis twice. Thank you for that contribution. Okay, so a positive value for the discriminant, doesn't matter what that number is, as long as it's positive, there will be two x-intercepts. A discriminant of 0 specifically means that there is one x-intercept. Okay, if the discriminant equals 0, it means the vertex is on the x-axis. Your parabola will either look like that, or it'll look something like that. Okay, it only touches the x-axis in one spot. If the discriminant is negative, again, it doesn't matter what the number is, as long as it's negative, there are no x-intercepts. So that would be the situation where you've got your parabola that, over there somewhere, or over like that, right? It does not cross the x-axis. And those are your only options, right? If you plug something into a formula, you're either going to get a positive number, 0, or a negative number. And for either of those cases, that is the result. 2 x-intercepts for a positive, 1 x-intercept for a 0, no x-intercepts for a negative. Kylie?
Can all of this go on the help sheet?
All of this can go on a help sheet. It's all under that key point. Yes, indeed. Okay? Questions so far? Why? Okay. So below now, we basically have just kind of a review of a lot of stuff that we've done before, finding the vertex, finding the y-intercept, what direction it opens, all that stuff from PO54, but now including also how many x-intercepts the parabola has. So let's just look at I'm just going to rewrite the numbers 2, 1, 0 here just to minus those. The discriminant itself, b squared, right over here, b squared minus 4ac. So look at this first one here, 3x squared minus 6x plus 7. Who remembers what direction this parabola will open, or at least how to tell? Noah.
It'll open up.
Because why?
The x squared is positive.
Good. The a term, that 3, coefficient of x squared is positive. Therefore, we know the parabola will open up. Okay. How do we calculate the vertex? Walk me through that process. Aiden.
Negative b over 2a.
So the x value we find from negative b over 2a, which in this situation, what's that going to look like? Plug those values in. What's it going to look like? What?
Negative 6 over 2 times 3.
Yeah, and because that b term is negative, why it said negative 6, how's that going to look like in the formula? Positive 6, right? So if you want to write negative 6, that's totally fine, but it ends up being a positive 6. You could probably do this one mentally. If you do put it into a calculator, though, remember that the denominator has to be in parentheses. Okay, the way a fraction, what it means as far as order of operations, is that each part of it is done first. Okay, so if you were to put in your calculator 6 divided by 2 times 3, you're going to get the wrong answer. That 2 times 3 needs to be in the parentheses. So 6 divided by 6, which equals 1. Okay, and again, that's the x value. How do we get the y? What do we do with that one? Yeah.
Plug the x into the equation.
Yep. Go back to the original equation. Okay. Plug our x in. 3 times 1 squared minus 6 times 1 plus 7. Again, when using a calculator, I highly recommend you use parentheses to show that you're multiplying the way I've written it here. Otherwise, you run into the possibility of messing up signs when you square, and it could just get messy. So if you use parentheses every single time, then you don't have to worry about, do I need them? Do I not? Use them all the time. Yeah?
The answer is 4.
4. Do I have a second on 4?
Yes.
Yeah.
No.
What did you get?
I
Okay, so don't speak up.
6.
All right. Vertex, 1, 4. How we got that 4 is we just plugged 1 into our equation. 3 times 1 squared is 3. 6 times 1 is 6. 3 minus 6 is negative 3. Plus 7 is positive 4. That's where that came from. Kylie.
What about a different way that we could do the y and the y for the vertex?
I think you're thinking of the axis of symmetry. To find the y, you're pretty much just plugging it in. Yeah. Y-intercepts. What's the y-intercept? And tell me how you found it. Kylie.
0, 7.
And how'd you find it?
That's the C term.
Right. The y-intercept is just that c term. 0, 7. Question why?
The first one's always 0, right? The x.
Yes. For a y-intercept point, the x value is always 0. Okay. So thus far, we've done nothing new. This is all taken directly from CO54. It's worth reviewing though, okay? Because knowing how to find all of these things is going to come up again later on, and the more you do it, the more you practice it, the more that you just become familiar with it. So nothing's new. CO58 now is where we're going to talk about how to answer this question here, the number of x-intercepts. So what we do is we go to our discriminant, b squared minus 4 times a times c, and we just plug in the numbers. Okay? Now because b is negative 6, here's where parentheses do matter. Here's where you need them. But again, if you just do parentheses every time when you square something, you're not going to make the mistake of not using them when you have to. Right? If you do something the same way every time whether you need to or not, then you're always going to be right. The reason why we need them here is because our b value is negative. And like we've talked about in your calculator, this is different than that. In your calculator, negative 6 squared without parentheses is negative 36. Because it squares the 6 and tacks on the negative sign. What you want it to do is square -6, which means -6 times itself, which is going to be a positive 36. Okay? If you use parentheses every single time, you won't make that mistake of not putting them in. Okay? So -6 squared minus 4 times our A value, which is 3, times our C value, which is 7. And all we care about is this number positive, is it 0, or is it negative? Not so much what the number actually is, but its sign. So what is -6 squared minus 4 times 3 times 7? Negative what? -48. Do we have a second on that?
Yeah.
Okay. So because this equals -48, how many x-intercepts does this parabola have? 0. A negative discriminant means it has 0. Okay? The discriminant doesn't tell us what they are, only how many it has. Any clarifying questions on what just happened? Because it was magical.
I don't think it was.
Of
We're doing more.
course.
Yeah, we found it.
Okay? Let's do the next one here. Actually, let's do the third one so I can have more space to write. I'm not going to focus on the direction, the vertex, and the y-intercept because that's all review. You've done that before. Let's focus on the new piece, the number of x-intercepts here. Okay? So as it happens, again, our b value is a -6. Okay? But we're going to that formula, b squared minus 4 times a times c. At this point, no, we only have a couple minutes left. But you should be bringing a calculator to class every day. At this point, with the algebra that we're doing, it's not going to get any easier, as far as calculations. So have it at the ready. So they learn how to use it, right? Because if you don't practice the tool you have before the test, then it's really easy to make mistakes using it. So b is negative again. So the parentheses are required. -6 squared minus 4 times 9, our A term, times 1, our C term. Joey, 1? Do you have a second on that? Are you saying that equation equals 1?
No,
No,
number of x-intercepts.
because the equation equals
0.
0. Okay, all right, let me try. So this equals 0. -6 squared is a positive 36. 4 times 9 times 1 is also 36. And 36 minus 36 equals 0. Please tell me.
Do we have to do like the direction vertex?
Yes, you need to do that. I'm just not going over it right now because that's review. We've already talked about that. I'm focusing on the new part here. But because this equals 0, a discriminant of 0 means there is one x-intercept. That vertex is on the x-axis. Okay. Clarifying questions. Why?
Will there be a quiz on this one?
Likely.
What?
Queen not.
I told you I made all these during quarantine. I want to get use out of them. Jack,
Where did you get the -4?
that's part of the formula. B squared minus 4AC, that 4 is always there. Okay?
How did you get the 4?
What's that?
How did you get the
We'll talk about that in PO59. This formula is like a piece of a larger formula.
We should just not do a test. We're doing so many quizzes. That could count as extra.
Yeah.
I'm expecting much better test scores because of all the quizzes.
No, that's not gonna happen.
Oh.
Everybody's gonna fail.
Well, I will choose not to believe you until I see the data. Arlene.
Everybody fail.
Yes, you have homework, Arlene. I'm glad you asked. Your homework is to do the rest of this page only. There is a second page, I believe. It's only 4 of them to go, 4.5. So yeah, don't do the second page. Only this first page. The direction, the vertex, the y-intercept, that's all review from PO54. The new part, the discriminant, is the number of x-intercepts. Not solving. You're not solving, just how many X-intercepts there are.
Oh, that's it? We have to just find the number.
No, you're doing all of it, but you're not solving the parabola. You're using the discriminant just for the number of X-intercepts. Okay? All right, I told you I could speed run that. That's how you math.
Don't
Like
read
and
the
subscribe.
line.